Hello, this is a tutorial about how to set up the Google accounts start from the beginning. So now I like to have a test account and I just search for Google Cloud on the search tab, and then we can start to create the Google Cloud account from the beginning. And by clicking the sign in, you need to either use your current Google account or you can create a brand new account for the Google Cloud. And what I'm doing here is just using a new email address to create an account for this. And it takes some steps to do the verifications. Like you need to provide your name, your email address, and the password, which uh, should be if it is secure enough. And then after finishing all of them, you need to verify it by getting the verification code from your email inbox, which should be a 6-digit number for that. And after that, you need your phone number, birth date, and also some personal information for that. After that, you need to also fill in like countries and some why you need to set up Google accounts, something like that, which takes few steps for that, and things like address, and most importantly, uh, how to pay. So in for my personal accounts, I was using my credit card for that, and there are also other methods for that. But anyways, you need a valid way for online payment in order to start the free trial or like creating the account. And after that, you can see the account is created successfully. Then after creating a account, you can go to the Compute Engine tab on the left side, which then click Enable API for that. This would take more than 1 minute to load, but after that, the Compute Engine API is finished, and then you can create a any computer engine on this part at here. And after this, go to the billing on the left side, which on the bottom right, you can see there you have like 380 Canadian dollars free credits for a newly created account, and then click upgrade on the bottom side, which will upgrade this account to let you really create some powerful compute engines or virtual machines. Otherwise, there are just some simple function computer engines available. Then after upgrading the accounts, we still need to increase the quotas in order to create our future server successfully. First, we go to the upper tab and search for quotas. Then go to the all quotas option. Here in the filter part, we first type in GPU and the GPU's origins per project. Here we can see now the current limit is 1, which is increased from 0. So if it is a new account, it should be 0, and you click on the left square and click Edit Quotas here. And you just change it like to 1 or 2. But for the first time user, I recommend to change it to 1, and then you will need to send a request for this, and after a few minutes, with the registered email account, you can receive the final decision results for the request for quotas increase. Usually, if you do not request for a ridiculous or a unusual range of the quotas. It should be passed, and you can check the results in your email inbox. After that, you also need to increase the quotas for the persistence SSD storage, which since we are going to uh, create a server in the region of US Central 1, and we just first typed in the region, which is US Central 1, and then type SSD. Here we can see that for the option of persistent disk SSD, which should be 500 GB for new accounts. And here, like the previous GPU, we increase it to 5 TB by sending a request. And you will also get the final results by checking the email sent to your registration email. And after that, all the previous prerequisites are satisfied and we can start to create a new instance. For the user setting, I will name the server as the AlphaFold server because we are going to run AlphaFold on this server. And for the setting, uh, in the GPU and CPU part, I will choose GPU with Tesla T4 because from my previous research, it is the most cost-efficient one. And for the CPU setting, we set it with the N1 High Mem 8, which should be the most suitable version because it needs more memory for running AlphaFold. And for boot disk, we will need to increase the size of the boot disk from 10 GB to 100 GB. And more importantly, for the advanced options, we need to add a new persistent disk by clicking the disk and add new disk option. So that's why we need an increase in the SSD quotas because we need a large storage space for AlphaFold database. Here, we will modify the size from 100 GB to 3072 GB, which is 3 TB for the full database. And other options, we do not need to change the other options and just save it. After that, by checking that all settings are correct, we can click the create to create a new server for that. The creation usually takes 1 or 2 minutes, which is pretty fast. And after that, if there is no problem, you can see on the VM instance pages that our server is running. So after creating a cloud server, we can directly click on the SSH option to log in from the web browser directly. But I recommend to generate a key pair for you to log in from local later. And for this purpose, I have already generated one key pair for that, which is the AlphaFold key, and the username is the AlphaFold user. And I will upload the related uh, key pairs to the Google Drive. But if you want to generate a new one, there's also a Linux option for that. Uh, First, you need to go to the metadata part on the left tab, and you can see the originally uploaded key pair for public key for the alpha user. But if we want to generate a new one, we need to go to the Linux terminal and do it by commands. Basically, you use the SSH keygen commands, and after generating it, you can see it on the folder you pointed to. With the private key and public key created in the folder, you just go to the metadata on the Google Cloud and copy all the contents in the public key and paste it into the SSH key by creating a new item on it. Then, after successfully creating the public, uploading a public key on Google Cloud, you can use the new private key to log in to the cloud server locally. Like what I'm doing in the Linux server, a Linux window now. Or if you're a Windows user, uh, one way is to set up the remote desktop later and you can use the Google browser to log in. Or you can download a SSH login tools called Mobax Term, which will help create a terminal for you and help you to do such things. For login, you first need the IP address for the server, which can be directly found on the server statues on Google Cloud, and then you just use the SSH command with the key pair's name and the private key, like in a format like this, and I will also write down the detailed format in a related documents. After that, also, in addition, you need to ensure that the private key is you are in a folder that stores the private key. And then by using this command, you can log in successfully from your local terminal. After successfully logging into the server, we need to download a database, we need to download a database, which is in the first priority. Uh, Basically, for the following comments, I'm referring to this post about running alphafold on Google Cloud. And since it is first time for running the initialization, we still need to input the comments manually. So by copying and paste to the command line, we can do it step by step according to its instructions. Basically, the first step to do is to making the file system and attach the 3 TB SSD disk to the operation system. And after that, we need to download some tools like the Area to C and our sync, which is essential for the following database download. And after that, we also need to download the Git, which is a tool for pulling some pulling some managed database from the internet, which is especially the GitHub. And after that, by using the git clone command and with the tools download finished, we can go to the downloaded folder called alphafold by using the change disk command and go to the scripts subfolder in alphafold where it has all the commands inside. You can see there are sh files called download all data.sh, which helps you download all the database in one command. And there are also some separated files which will function as downloading each separate parts. So for downloading all data, we only need to type the following commands to run it, and then the whole downloading process will take about uh, in ideal cases, about 5 to 6 hours. Um, but usually you need to take half a day to ensure that in case of a not ideal situations. In case it's too slow to download it in one process, you can also open multiple processes for downloading the database, which can increase the efficiency for into 2 times or 3 times. So basically, what you need to do is just open a new window and keep SSH. Also use SSH command to connect it to the server. And for the two windows, you run like each subparts individually. You can do it also for like 3 windows or 4 windows. But also a thing to need to mention is that we are going to only download the BFD database. For a small BFD, we do not need that because we are downloading the full database for that. If all the data sets are downloaded successfully, you can go to the download folder and see all of them there. And for detailed content, you can go to the DeepMind alphafold GitHub repository for that. And with the full database downloaded and inside your SSD disk, you can go back to the Google Cloud's interface where you can and select disks option in the left tab where there you can see the 3 TB SSD there. Uh, and by clicking the 3 dots on the rightmost side, you can see the option of create snapshots. By clicking it and do not change anything and clicking create, you can create a snapshot for the disk to help you to quickly restore the disk without using to download the full database. And you also do not need to retain a 3 TB disks if you don't need it. And that's the advantage of snapshots. And I recommend to create a snapshot for the disks as soon as when you have finished the download. And after that, in the later times, you no longer need to download the database again. Okay, let's get back to the AlphaFold installation. With the database installed, as we can see here, all we need to do is to, uh, with the gits installed, we can just git clone the pipeline for the AlphaFold, which I will put the link uh, in the document related documents. So we still use the git clone command to clone the related pipeline scripts and data files into our server. With that, we can copy the initialization shell script from the Party Lab pipeline to our uh, alpha fold or to our home folder, and then if it cannot be executed directly, this is because the we need to change the mode of it using a command called chmod 755 and then put the file names after. So after that, we can first execute initialization1.sh by using dot slash plus the file name. After that, since all installation or initialization should be finished automatically, uh, you just need to enter yes for do you want to continue the process. And after the initialization one is executed, continued on initialization 2, which will further install the uh, GPU driver and also set up the Docker images for AlphaFold. In the process of initialization 2, if you see a box titled with NVIDIA SMI and inside has the Tesla T4 for it, this means that the GPU driver is successfully installed. This process will usually take longer time about 15 to 20 minutes. And if you have met any possible errors in the file, one direct way for troubleshooting is to open the initialization files and execute the commands line by line to see where is the problem. So probably the reason is that you have just installed it before, so it has some error message, and you can just ignore it and finally see if. Also, if you have met any error that you didn't cannot find a way to solve it, the the way I recommend to uh, fix all kinds of error is to just delete this instance and create a new one for with exactly the same setting. And at that position with a new server, you first need to install the Git and then git clone the alphafold pipeline, and then without doing anything more, you just copy the initialization file, change mod, and then run it directly. In the case of the unchanged server, the initialization file should always pass successfully. After the initialization too, see by typing the command docker images, you can check if the alphafold image is installed. If it is installed, this means that the initialization should be successful. After successfully installing the alphafold, we can start to run some tests on it. So here's the folder I prepared called seek inputs, which contains a bunch of FASTA files, and alphafold use FASTA files as the input, where it contains the amino acid sequence info, and it can be a single chain info or a multiple chain info, which is marked inside the file. And here for the pipeline, I wrote a shell script for uh, like running all the files inside a folder for one call. So basically, the shell script is called run alphafold.sh, and if you do not know how to run it, first way is you can see the uh, content of the folder by using the vim, and you can see in the main part it is just the Python command for running alphafold, but has many options encapsulated. So I know you can also directly run it without the command to see its functions and how to use it. So basically, it is /run alphafold.sh and put the input folder in the first command and output directory on the second command. And if there's no output directory, it is default setting to the tmp alphafold. So here, by running /run alphafold.sh and choosing the seek input as a folder, we can see that it is running successfully. And in addition, the no hop command and the ampersand symbol for that execution, meaning it will not be stopped accidentally, and you can see all the outputs will be stored into the file called no hop out, where we can use tel-f nohop.out to see it. And also we can use like the commands like top to view the current running process. In addition, we can run it in multiple processes. So basically, what you need to do is just to use no hop command, or you just open two terminal windows, and run two commands separately. In that case, like putting the two bunches of files in two folders, you can run these two processes uh, automatically, and after a certain amount of time, you just go to the output folder and check the results. And here is a typical output for the alphafold. Like it will output in the form of a folder where the PDB files are the ranking results, and ranked 0 means the best prediction with the highest scores. So usually we just take this one, and for the other files, it's just some intermediate files. And another important thing is the timings.json files, uh, which records all the timings, download timings of the files, like this. So as you can see, there are many unrelated files. So that's why uh, I also wrote a shell script that extracts especially the ranked 0 PDB files out from the results, and like naming it with the folder name. So like for this folder, which is high brightness 1, uh, the ultimate results will be like it will be extracted to a certain designated designated folder with the naming of high brightness 1.pdb. As it is not easy for non-professional users to use Linux terminal always, so we can instead set up the uh, remote desktop from the Linux server side. But to set up it, we still need to use the command line arguments. So starting from the alphafold pipeline, which has a file called setup_remote_desktop.sh, we first just change its mode to 755 and then use /file name to run it. The whole process would take around 10 minutes, and after it has finished in the last stage, it'll ask you to enter a 6-digit PIN code for your security login. And after setting up, you can use the web browser with link, uh, especially the Google Cloud and Google Remote Desktop interface link, which I will attach in the related documents. And in that, you can log in through the web browser without using the Linux terminal or mobile Xterm. If there is any error or problem after the setting up, the best way is just to run all the commands line by line again, or you should delete the instance and do all the stuff again in case if there is some missed operations. Still, after the setting, you need to wait for a few minutes till it is activated, and then if you should see the server with its name on the remote desktop interface where you can enter the PIN code to log in. And so here you can see after login, we have the remote desktop, which is in the minimum style, but it still has the file system, and where we can now use the install of PyMol and use it for visualization of our previously produced PDB files. Just by typing the sudo apt-get install PyMol, we can install PyMol, and with the graphical interface, we can see the PyMol's illustrations. And then with the remote desktop setup, the next step is in the case if you want to upload something to modify the pipeline, or you need to transfer something to the local. And for the first, like modify the pipeline, you can use the GitHub related commands or the git commands to do that. So, if you are very new to the git command, I recommend you to see some tutorials about that because uh, there are a lot amount of content in it, and I cannot speak often in details. But basically, what our pipeline will need is just git uh, add, git commit, and git push. That's all of it. And also, due to the recent GitHub push policies, you may need to generate a access token for our repository, or uh, I will generate a token for the pipeline repository, and it can be used in like 2 months or 3 months period for the push. So for the detailed commands, you can just see what I'm doing in the remote desktop terminal, which will ensure that the push will be successful. And then for the transferring the file to local, we will use the scp command, and we should execute the scp command in our local terminal, like Linux shell or the mobile xterm terminal. So basically, it is separated into two parts: sudo scp -i and the private key, which is used for accessing the server. And then if you want to transfer the file from server to local, you need to put the server related info in the first part, which is like the the username at IP address, and with the detailed folder name or file name. And if you're using the folder, you need to add -r in the front for like indicating it's transferring a folder. And for the second part, it's just the local folder locations. If you just want to put it right here, you can just add dots to indicate the current position, like the position where you store the private key or the position of your current folder. And for the other way, like you want to upload some things to the server, you can also use cp command, but with the reversed position of the local position and the server positions. So what I'm doing here is just like from transferring a local PNG picture to the server, and after that you can see if this scp command line is executed successfully, you should see the PNG file in the meantime right after the scp transferring. So suppose that you have used a server for several days but found that the setting is not as satisfying. You want to edit it, and it is pretty a simple way to add. There's a simple way to edit it on the Google Cloud. Basically, you just need to stop the server on Google Interactive Interface, and after it is fully stopped, click into on the name of the server where it should show the detailed info of it, and there is an edit button on the top option box. So inside you can just edit the settings as you like, and if after all the settings are finished, resettings are all finished, you can click save to save the settings. If there is this change is okay and there is enough resources for changing the setting, it should take some like 1 minute or 2 minutes. And after that, the resetting should be completed. But uh, for most cases, if your data is backed up successfully, I recommend you to, instead of doing the resetting, you can just restart the server in case of that, because there may be some potential issues after the resetting, like the GPU detection and also like the remote desktop setup. These may all have some potential problems, which will be annoying. So in the next part, I will always introduce how to reinitialize a server from nothing if you have a snapshot for the disks. Um, So here we'll talk about how to restart a server from the beginning in case you have a snapshot that backs up the disk that already have the fold size database. So here we can see we have a snapshot for that, which is called the DB snapshot. And then we just go to the disks option in the left tab, and then we start from creating a disks. And for the disk source type, we choose the snapshot and use the aforementioned DB snapshot for that. And then if you do not want to create additional snapshot, you can just unclick the enable snapshot schedule for that. But if you want one more backup, you can also enable that selection. And it takes usually 2 or 3 minutes to recreate the alphafold database, which is 3 TB disks. And after it is created, uh, here we have a full-size database for that, and we just go back to the VM instance page and start creating a new instance. But here, different to the attach a new disk, we just click on attach existing disk, and then we can select the previously created database for that. But a thing need to mention is that you need to ensure that the region you creates the server and the region you created disks should be the same. And in this case, you should be able to find the disks successfully. And then after a normal time for creating a new server, you can see it is successfully set up. And by using the new external IP and the login ways for logging, like the MOBAX term or the terminal, you can log into the server and do the further operations like what I said before. And that's most of the most important parts for running an alphafold on Google Cloud starting from nothing. And if you have any specific problems or met any not problems that you do not know how to resolve and I haven't mentioned in the video, you can directly contact with me or send an email to me, and I should put my best effort to see how to address that issue. And also, if you have any unclear points about the comments, I will put all of the detailed comments in a related document, and I will attach a link in the description of the video. So that's all of the setting up and running AlphaFold on Google Cloud starting from the beginning.